Hello, my name is Rez. I am a professional game programmer. I do electrical engineering as a hobby. This is day 13 of our advent calendar. It's this guy right here. So let's see what we got. Day 13 is, it is an IC of some kind. That's super fun. Let's see. Try and bring it up here to the camera. So here's the chip. You can kind of see the part number there. There we are. Yeah. Okay, well, that is the chip. So let's see what this is. This is probably going to be much more interesting than just our little op amp. I'm very curious what we have here on day 13. All right, let's see if they have a spoiler. No, they don't. Okay, so day 13 is a full page spread. Behind the 13th door, you'll see a pre-programmed sound processor. Very cool. Soldered onto a small circuit board. We have our pins, of course, just like before. These are actually directly numbered, 1 through 10, 11 through 20. There's a considerable number of changes to this circuit at this point. It looks like we're kind of building what we had before. Yeah. Looks like we're building what we had before with a slight change here. So I expect there to be several, let's see. Guy's there, that guy's there. So nothing changes with this output or this capacitor or this resistor. This looks like it's the same, except that one of these capacitors is being removed. We'll pull this down a little bit more. Yeah, one of these capacitors is removed. So let's set this back up. There we go. So now we just have the 2 capacitors instead of the 3. These look like they're still there. Okay, so instead of this being shorted to ground through the switch, and these switches are gone now. Let's pull both of these guys out. This now goes to this thing. So I don't know that I have enough room to put this in here. No, I don't. So I'm going to have to spend some time kind of rebuilding this little board. I'll be right back. Okay, I think I have this hooked up correctly. I'll pull this back a little bit. Kind of do this. So I had to pretty much rewire the entire thing. There's just not a lot of room on this board. So that's where we're at. What I ended up doing was kind of shifting everything to the right. I've still got this little trimmer here, this little slider. We've got our capacitor here. All this stuff is pretty much the same as it was before. Nothing's really changed here. All of this is kind of the same. We're using only 2 capacitors this time, so it's the previous, it's not day 12, it's day 11's circuit, if I recall. And this sort of divider here is still the same, except instead of tying this to ground, this gets tied here into whatever that is, pin 15. Is that right? 20, 19, 18, 17, 16. I'm wrong. Pin 16. We're tying it in there. This thing is hooked up, so we've got, looks like pin 9 going to power. We've got pin 10 tied to ground. We've got pin, whatever this is, 7, I think. 1, 2, 3, 4, 5, 6, 7. Let me make sure that's right. 1, 2, 3, 4, 5, 6, 7. Yep, we have 7 tied to ground here. And we've got this capacitor going from pin 9 to ground as well. Now, this is an interesting... You see this setup quite frequently. I mean, this is everywhere in electronics, where you have the power rails, so basically power to ground right at the site of the chip. You have often a capacitor there, and that helps with filtration and all of that kind of stuff. kind of looking around to see if I can see an example of this. I don't have a lot of projects sitting here on my bench, but it's a very common thing that you'll see if you open up any electronics. A lot of chips can be very sensitive to changes, and one thing that capacitors are really good at is resisting changes in voltage. They're pretty good at trying to keep voltage relatively steady so it doesn't kind of wobble. It stays relatively stable, filters out a lot of the line noise and that kind of stuff. So for chips that can be sensitive to that kind of thing, you will often see that kind of setup. And here is an Arduino, and this is just an example of this. Let me change the focus a little bit. There we go. So we've got this part right here. That is a capacitor from V in to ground. If you were to look up the schematic, it looks like it is C14. So that's going from their, well, that's their VCC to ground. So that's the power coming into the actual circuit itself. So that is what that little capacitor is. So like I said, you see this, and often they're physically placed as close to the actual pins as possible. So that's why this guy is physically placed here. I mean, you could electrically place it way over here with all these other ones, but you want to place it as physically close. I think that's this guy. I think this guy's a one as well. So here, 5 volts to ground. Here's another one. And I'm not sure which one of these is the VCC, but they're both the same. They're both the same capacitor. In that they both serve. Excuse me. They both serve the same purpose. So that's an example using an Arduino Uno in this case. And you can find the schematic for the Arduino Uno and the whole, the board layout and all of that kind of stuff online. It's open hardware, which is one reason I really love Arduino. Okay, back to this. That's all that's going on here. I haven't actually turned this on. I have no idea what's about to happen, but let's find out. I've turned this down. I don't know if 100 milliamps is going to be enough. Get a little bit of a buzz going on. I'll turn this on. Oh, my light. I always do this. Let me refresh this LED. There we go. So we get a little bit of a buzz. I'll turn this up so you can hear it. It's going up and down. Hopefully you can hear that going up and down. I'm just turning this. I don't know if this will fit in here. No, it won't. Right, so it's getting to where the frequency is too high. There we go. I have no idea what this chip actually does. I would need to look up the chip part and all that kind of stuff, but that's basically what we have right here. So it's just switching between these two frequencies. That's basically what it's doing right now, which is super fun. I imagine what it's doing, if I were to crank this down a little bit, I imagine what it's doing is it's essentially putting some signal here or whatever to kind of do what we were doing before, but in a more of a pulse. Like if I short this out. See, I just get one of them. If I short it out, so I think that's basically what it's doing. So that's what we got. That's day 13. So that's fun. Now we're starting to get. I wondered if at some point we were going to get some kind of chip. They had a video game one, which I did 3-4 years ago now, which was super cool. And that video game one was basically, here's a chip, let's play with the chip. And I think that's what we're doing here. we have a chip. We're going to play with the chip, and we've got this op amp that's going to kind of amplify a bunch of stuff for us. And I think what we have here, now that we're about halfway through, a little over halfway through, I think this is the core. I think we're going to have other little parts that are going to play around with stuff. We're probably going to do more stuff where we hook up into this chip, but that's it. As an aside, unlike some of the other ones, I wish this had better descriptions as to what is exactly happening here. Right, we've moved some stuff. The sound processor, it just kind of tells us what's happening at a very high level, but it's largely ignoring, like, well, what actually is this chip set? What is it actually doing? And I'll try and dig into this and look this up in a bit. But that's what we've got. So that's it for day 13. I'll see you tomorrow.